Hey all, we're going to be looking at infinitely many solutions, no solution, exactly one solution, and just general manipulation of equations. So this question is asking, how many solutions does the following equation have? In order to figure this out, we have to distribute our negative 9 to both sides, or to both terms here. So we have negative 9x, and then it's minus 54 is equal to negative 9x plus 108. So at this point, we can identify whether or not it has no solution or infinitely many solutions or exactly one. How we can identify that is when you have the same exact, when you have one x term on each side of the equation, like we have here, we have negative 9x here on the left, and we have negative 9x on the right. If I were to add 9x to both sides, and let me erase this underline so it doesn't confuse you with division. If I add 9x to both sides, what happens is my variables reduce. I no longer have the x variable. And if I no longer have the x variable, all that's left are whatever numbers remained. And what we see, it says negative 54 is equal to 108. But that's impossible. Negative 54 can't be 108. That doesn't make any sense. So this must be no solution. How this problem would change with infinitely many solutions would be the following. If instead it said negative 9 times x plus 6 is equal to negative 9x minus 54, if this were our situation, we distribute the negative 9, we have negative 9x minus 54 is equal to negative 9x minus 54. And what we see here is on both sides of my equation, I have the same exact thing on the left and right side. So therefore, any value of x will be true. If I plug in 2 here, I'm going to get the same result if I plug in 2 here. These two sides will be identical. If I plug in 100 for x, they will both be the same value. And again, if I were to add 9x and if I were to add 54, I would get 0 is equal to 0, which is a true statement. Anytime we have true statements would be infinitely many solutions. When we would have exactly one solution is if the variable x, instead of being, say, negative 9 and negative 9, maybe it's negative 9x and negative 8x, or negative 9x and literally any other number except for negative 9x. So there just has to be a disagreement with the coefficient of x when it's by itself. Next, it says solve for x. These can be a little tricky, so it's really important that you watch what happens here. If I want to get x by itself, what you do is sort of counterintuitive. You want to get all the x's together. So I want to subtract bx to both sides. I want to keep all of my x terms together. So I have ax plus 3x minus bx is equal to 5. The reason I want all my x's together is because I want to solve for a single x. I don't want to solve for 3 different x's. I just want one x by itself. And when I have these x's all together here, they all have an x in common. And when they all have an x in common, I'm able to take that x out from each of them. I'm able to take ax divided by x and get a, 3x divided by x and get 3, and bx divided by x and get b. Now I have x multiplied by a plus 3 minus b. So to get x by itself, I'm going to divide by a plus 3 minus b. And our final answer is 5 divided by a plus 3 minus b. Now this could be written in different ways in Khan Academy. I'm pretty sure they don't care about what order it's in. So if you had, say, negative b plus a plus 3, that would be okay, or a minus b plus 3. Next, solve for x. Okay, so this one is similar but different, right? Because we have more variables. We have d and k involved, and we have x's on both sides. Again, I want to get these x's together. So I'm going to distribute the d to both of my terms. So it's negative 3d plus dx. Because by doing so, I'm able to have x such that it's not being directly added to that negative 3. I can now subtract the x over without like breaking the rules of PEMDAS. So here we are. Now, how we solve for x, you could do it two different ways. You could either subtract dx or you could subtract kx. What I'm going to do is I'm going to add 3d over first. So I then have dx is equal to kx plus 9 plus 3d. And I added the 3d over because I want to have just terms that have an x with it on one side of my equation. So I have dx, which has an x by itself right now, but I need kx to go with it. So I'm going to subtract kx from both sides of my equation. So I get dx minus kx is equal to 9 plus 3d. Now we have our x's on the same side of the equation. I'm able to factor out an x. And then once I factor out that x, I'm able to successfully get x by itself by dividing d minus k to both sides. So my value for x is 9 plus 3d over d minus k. And just because I think this is a challenging concept, we'll do one more of this. I think this one's a little easier than the last one. So if you do want to pause the video and try it on your own, do so. But if not, it's py plus qy is equal to negative 4y plus 8. I'm going to add 4y to both sides. So we have py plus qy plus 4y is equal to 8. Factor out a y because there's a y in every single term. So I have y multiplied by p plus q plus 4. I'm going to divide both sides of my equation by p plus q plus 4. So y is equal to 8 over p plus q plus 4.